So how do I know it's start recording or not?
It's recording.
It is? Okay, good.
Yeah, it is.
All right. So linked list. Okay. We have another two type of linked list. So far we know it's forward linked list. And let me just shut off my video, shut off my stuff. Okay, it's all right. We'll leave it there. Okay. The forward linked list and double linked list. And then there are people who are also using the things called circular linked list. What is a circular linked list? It's a linked list pointing to himself. So if the linked list is empty, can you see the drawing there?
Yeah.
If the linked list is empty, then it's just pointing to a null. And if there's only one item, okay, the items next is pointing to himself. So that means there's only one item in the linked list. Now, if you got more than one item there, basically it's really the tail guy. So this will be the first guy. And who is going to be the tail guy? This guy is going to be the tail guy. The tail guy pointing to the head. So the last guy pointing to the first, or the tail pointing to the head. Let's just make it a linked list. And I think this is a very simple concept. I think you can understand that. The whole question is this. So when do you use linked list, circular linked list? Anyone has any idea? When do you use circular linked list? In real life, okay? In real life, you will see some circular linked list, okay? So for example, have you ever been to the shopping cart? Well, go to Costco, you got all kind of shopping cart, yes? Okay. And for the shopping carts, okay, if you think of a shopping cart as a linked list, then the guy who take the first guys and go out, and when he's finished, he's going to come back and put it into the bag. And he's going to come back and put, the next guy's taking it and going to come back and put in the first. Very much, that is a linked list structure, technically. Technically, it's really a linked list type of structure. Yeah. And for circular linked list, yeah, many applications used is that, suppose that I have, like in my previous job in Cisco's doing networking, and we need to assign buffers to other people. Well, when there's interfaces coming to get the data, and we got a whole bunch of data here, whole bunch of buffers. And then we can give the first buffer to the first guy, the second buffer to the second guy. And when this side is finished, you will come back to the end. Does it make sense? So very much is that there is really a circular linked list. And later on, when we're talking about queues, and we will have a very similar situation of the circular linked list, because that if you are queue, you take the first guy out. Okay. Suppose we implement a queue with an array, okay? And there will be A, B, C, D, E. Okay? And then the beginning is A. And then when the A goes out, it comes back to the end. It's going to be A on the other side. And the whole thing is that this becomes a circular linked list. If you're going to reuse the storage, that's become a circular linked list. So if you're not quite clear about at this moment, that's okay. But just keep in mind, there is another data structure on the linked list is circular, all right? And later on, I think in another 2 weeks, we were talking about queues. And when we get to the implementations of the queue, then the circular linked list will be a lot more clear to you. Another type of linked list, okay, is that the linked list with header and trailer nodes. What does this mean? Okay. That means any linked list, when we create it, okay, it automatically has two lists in there. One is called the head, and one is called the tail node. And why is this? So if the linked list is empty, he will have two nodes. So at least the minimum number of elements in a linked list with this type of linked list is 2, because you need to have a header and you need to have a trailer. Okay? Why? Why you do that? When you do a linked list, even forward linked list, or double linked list, in either way, when you do operations like insertion, deletion, all you always need to do is consider all the boundary cases. So what are the boundary cases you have? The boundary cases are, when you do insertion or deletion, any boundary cases are, is it empty or is it full? Of course, the linked list is not going to be full, but circular linked list is going to be full. Okay? Because circular linked list, you have some fixed number. Okay? But the linked list is empty or linked list is full, or you insert at the beginning, or you insert at the end, or you insert in the middle. Now, if you consider that insert in the beginning, insert in the end, or insert empty, or insert in the middle, but if you have a linked list with two nodes, like basically it's a boundary. You put a boundary on that. Then everything you put in the middle, all you have to consider is insertion or deletion, only one case is in the middle. Does this make sense? Okay. So
can you repeat that again?
Okay. If there is, the linked list has two nodes already in there, okay? Then every time we want to do an insertion or deletion, we want to insert or delete the boundary cases we have. We don't need to worry about empty, right? Because the linked list is not empty. The head is always pointing to the first node, so they cannot be known. And we don't have to worry about full. Well, linked list is not full, but we also don't need to worry about insert at the beginning or insert at the end. All you have to do is insert in the middle, in between. It's always, when you do insertion, it's always in between two nodes. Make sense?
Right, so the head and the tail are just like boundaries, and we can only like insert it like a node in between.
Because let me go back to it a little bit more. Okay. For example, if you do insert a node, look at this picture. When we are doing insert a node, it doesn't matter if it's a double linked list or it's a forward linked list. Okay. Insert anything in there, we have to consider cases. Case 1, if it's empty, we have to deal with that special case. Case number 2, insert at the beginning. Okay. Case number 3, insert at the end. Case number 4, insert somewhere in between. You with me?
Yeah.
Make sense? Okay. Now, imagine if you have a linked list, double linked list, or just, this will be the forward linked list, yes? Okay. Suppose that any linked list automatically carry a head, or normally carry the first node, the left boundary. Well, I should call it the left, and then this guy is the right. So you have the header and the trailer field already in there. When you create it, it already got two boundary cases there, boundary node. Then, first of all, when you do an insert into this data structure, you don't have to consider it's empty or not, because they will never be empty. And do you have to consider the beginning of the non-empty list? No, because it's always, when you insert, it's always going to be here, not before this guy. So these cases, you don't have to worry about it, okay? Then you want to insert the end of a non-empty or not. If you can insert over here or not, you don't have to, because it cannot be, because you cannot go beyond this right node.
So, Professor,
Yes,
these two header and tailor or like trailer nodes, they're different from like a head and tail pointer, correct?
that's correct. That's correct. That's correct. So the head pointer is this guy, right? Okay, and the tail pointer is pointing to him. Make sense? Okay, so this is your data structures of the linked list, but this is the actual nodes on the linked list. Clear about the concept?
Okay, that makes a lot more sense.
Okay, so all you are worried about is really just this case. So what does this do? This is that it makes your algorithm a lot simpler. Okay? So what, are we all clear about this point?
Yeah.
Okay, and the same thing for deletion. Look, you delete any linked list, you have to consider is it empty or not, okay? And is it the first node? And then is it somewhere in between? And is it the last guy? Oh, well, they should also consider if it's the last guy, if you got a double linked list, okay? So you don't have to worry about that. You don't have to worry about that. All you have to worry about is this guy, yes? Make sense? Okay. So if you have this scenario, a linked list with both header and trailer, then it simplifies your insertion and deletion of that, the whole linked list. Okay, so what does it take? It take would be, you need to set a header and you need to set a trailer. Basically, it's when you construct the linked list, you add two nodes in there. Okay, so how do you do these two nodes? And that's another question, okay? And so the question of this first node got to be what? Got to be, if your node is sorted, okay? That header node has to be the smallest of the guy, and the end guy will be the largest of the guy of the data. So suppose we have a stock node, okay? And the stock is sorted by alphabet. And then in that case is that if we're going to create a header node, which will not be any of the existing stock node, it will be something which is less than the first stock node. The first stock node could be A. But in this scenario, this could be, 3 or something. I don't know what's before A, okay? And if the node is sorted by student ID, for example, okay, then the first node would be the header node. What we could create would be create something like -1. Yeah, and the trailer node could be 999999999. Make sense? And so very much is really for this type of linked list to work is that you need to have a convenient way of creating the header node and the trailer node. And then when you create it, when the constructors of the linked list is called, then automatically generate these two nodes into the linked list. So the linked list will never be empty. Then, so when you go to do your insertion, deletion, you don't have to worry about is it empty or not. Or is this in the first node? Is this not? All you have to worry about is this somewhere in the middle. Good. Any questions? So those are the two types, okay? Just to summarize it, it's right. What does it do is to serve simplified insertion and deletion algorithm, okay? And those two nodes are not part of the actual list. So this is really just for creators, that for the guys who are manipulating these objects' purpose. And actual list is located between these two nodes. All right. Okay. Linked list does have STL with the linked list, and the linked list STL, if you look at those commands, the linked list constructor, and the push front, pop front, the front to back, remove if unique, and then sorting, merging. Yes, there are many operations, but we are not going to go over those. But what you need to know is that there is a STL, this template library, which have all the linked list is one of the temporary library. Just like array and the vector, I think many of you have used the vector. The vectors and arrays are also part of the template library. So how to use those? I think those are really quite straightforward to use, and we are not going to cover those part, okay? But what we are trying to focusing on is focusing on the why those linked lists are created. All right. Okay, so any questions about those type of linked lists? If not, I will go in and talk about the hybrid linked list, which actually is used quite often in the industry too.
Professor, I have a question.
Yes, sure.
Is it like from now on you would want us to utilize the header and trailer node for, like, for example, a test when making a list?
Oh, do I want you to use it in I would like you to do the exercise on it, okay? But I think in most of the cases we do a test, we are not going to test really want you to always use those header and trailer node.
Mm-hmm.
There's a reason, okay? When you study, you want to study the harder reasons or the harder algorithm. The harder algorithm is that there's no header and no header node, and there's no trailer node. Okay, and because first of all, it's actually there are two more nodes there, and those two nodes, you may not be able to find the appropriate one. I hope you understand that. Okay, take one example. If you think that the A is that the least of the possible case, but what if somebody come up with another language or another method which would have to insert before your header node? Then very much you are changing the structures you have. You're adding more constraint to what you can accommodate on your data structure. Is that clear? So for test, as long as you understand there's a header, there's another way of doing it is putting the two header in there. But for your exercise, like in your lab exercise, I would prefer you not to do it.
Okay.
Okay. All right. So let me jump to the other part. Okay. The other one, it's I want to talk about this. I want to talk about hybrid list. Oh no, this guy. Let me try this guy. All right. Can you see the screen?
Yeah.
Okay. So what is a hybrid list? Remember, so far we keep emphasizing there are two types of basic data structure: array and linked list, right? Okay. So out of those two data structures, are there any combinations of this? And they are. An absolute yes, because those are the things that the engineers use all the time. Okay, so look at this data structure. This is that array of object pointers. So very much is what? You create a linked list, okay, with an array. Okay. So if the linked list is only contain the pointers to that guy. So let me see if I can draw it. No. Oh, sorry. How do I do this? Here we go. No. Just bear with me, okay?
I'm sorry, Professor, but are you having each array element to hold a linked list or something else?
Just 1 second. Let me get this one first. Wow. Like, okay, so I'm going to use the pointer then, right? Okay. So say the question again.
Are you having each element of an array to hold a linked list, or is that a different application?
Each element of this array, okay, is only the pointer pointing to the object.
Mm-hmm.
Okay, so the array is actually an array of pointers. With me? Okay, just like this guy. Okay, so this head would be suppose this is array is A. This head will be A0. Okay, and the pointer, the pointer, so the address of this guy will be A0. The address of this guy will be A1. Well, I shouldn't use the A, okay, sorry. and this guy will be A2. You with me?
Oh, I see what you're doing now. Okay, so you're like assigning the nodes with an array.
That's right. So it's an array of pointers, and each pointer is pointing to an object. You with me?
Mhm.
Okay. So how good is this? Okay. How good is this? The good thing is these two things. One is this would be able to handle all the variable size stuff. And we don't really need to do the copy. Why? Because this could be like, for example, if this guy is a video one, yeah? This is a video. This is also video. Now you got one video, two video, three video, then this head is going there. It's all, you can do it by linked list, or you can do it by having array of videos. But each one of these is a video pointer pointing to the actual video. All right. Why is this? This is that then you have array simplicity. What's array simplicity? Array, you can actually just go to the number 2 or number 3 or number 5, go to direct access. Yes? Okay? And then you can also have is have all the different variable size objects get stored into the same data structure. Right? And then when you do, like, if you want to insert something, okay, say, suppose I have this D and we want to insert somewhere in between, okay, want to insert over in the middle, then I don't have to do object copy, because then all we're doing is we just change the pointer. This guy is pointing there, and the next guy is pointing to this guy. Basically, the moving the pointers down on the array can accommodate any insertion in the middle. We don't have to move the data. That's a very important concept to understand, is that if we put ABCD, this whole thing, ABCD, then if we insert something in between, we have to push down everything, right? Right. So that's what an array is. And the benefit of linked list is that if I want to insert something in middle, we have to do is changing the pointers. So we don't have to do the copy of the data. And so the insertion will take much faster. Okay? And by using this data structure, instead of linked list, we achieve the exact same benefit or similar benefit. Basically, you are moving only a byte of the address. We okay? Any questions so far? And so you don't have to do the copy, you don't have to do the variable size, and every time insertion deletions will be all done by manipulating the pointers. Okay? But we also have because this is an array of pointers, it's an array anyway. So we have all these things about the size limitations and what's the maximum numbers. Okay? Very much is what arrays limitation has, we have the same thing, except that we have some of the benefits of insertion deletion. We don't have to deal with the big size of linked list. Good? All right. So let me see what, can I do this? No. Oh, I better clear that guy. All right, so take a look at this guy, okay? So really, this data structure, this kind of hybrid data structure is commonly used in the industry for combined advantages of linked list. There's no copy and variable size, and direct access and array in the simple operation. Okay, so both dynamic and static array method, because it's an array, it can be dynamic or static method. Okay, can be applied here, and that's we have another. So if you defined that hybrid data structure, this will be what it looks like. And if you look at this, this is very much just like when you define an array. Yeah, and also because of this, you achieve similar functions of linked list, except that you don't have to create a linked list. So when you don't create a linked list, you do not have a linked list node issue. All right. Another way of doing similar thing is also you can implement a linked list with array. Any questions about this approach?
What's the con of using a hybrid list?
What's that?
What's the disadvantage of using a hybrid list?
What advantage of using it?
Disadvantage.
Yeah, the advantage is right here. Okay. You can do direct access. You want to access the number 70 items in a linked list. You can go direct to it. Make sense? It's a direct access. Okay. And also the other one is that you can also, if you do an insertion or deletion, you don't have to do any copy.
I think he's asking for the disadvantages.
Yes, there are disadvantages, but the advantage is insertion. Like for example, insertion here, okay? Yeah, you just complexity-wise, you say, oh yeah, insertion, you will take order of n because you need to move all the pointers down. Yes, that's true. But you move the pointers down is a lot simpler than move the whole object down if your object is huge. Clear? Okay. So the simplicity of the array and it's one of the advantage. Okay. And the variable size of the objects. Okay. You don't have to make a copies. Okay. If you want to remove this guy, you are basically to remove the pointers. You don't have to just take the whole thing out, copy it out to a buffer. You can just having these guys and go to a different queue. I'll give you one real example. Well, let me do an example in networking. Okay, so let me do it this way. Okay. So in networking, if we on the interface side, if somebody sent a package and that package wants to go to a network router, your package coming in from here and going out from this side. You with me? Or you could go out from this side. So coming in from here, go out from there. So if we receive a packet coming from here, typically how we do it is we create a buffer storage. And this guy, the data will store in here. Whatever the data will store in here. After it's done, we'll decide where the thing to go. Now, if we decide it's to go there, we will just go ahead and queue these guys, add these guys to this data structure. Does it make sense? Okay. So if this is, suppose this is an array, using array data structure, what happens is this guy would have to be filled in to the whole array, basically to copy this data structure over there. Okay. So a typical thing we do would be, or we just do a linked list. So when you want these guys to go over here, is really you just insert the linked list pointers into whatever this data structure array is, instead of doing a linked list. You can do a linked list, yes, but you can also do a array of pointers to the linked list. You follow? Because if we do a linked list, virtually we have to add another one of the pointers into this data structure. So make this into a struct and then put into a linked list. Am I explaining?
Professor. Hey, Professor.
Any question? Still not
I was like wondering, for hybrid list, do we like have to make a linked list first before making having the array of pointers like point to the nodes, or?
No. If you're going to do the hybrid in this way, this is not a node. This is because you know what is a node? The node is a object plus a pointer, right? One or two pointers. Yeah?
Yeah.
But what is this pointer for? There's no need for the pointer. His next guy is next guy. Is that guy.
Oh, okay.
So simplicity comes in is that you don't have to make a node. All you have to do is that just, the node and the pointer, and it just basically you put a pointer here. The pointer is put a pointer in the array.
So it's an array of pointers, pretty much.
Yeah, it is.
Okay.
It is an array of pointers.
It's like a two-dimensional array where it just holds pointers instead of like something else. In a sense.
That's one-dimensional.
Right,
Array of
so,
pointers is one-dimensional, right?
yeah.
I guess, yeah.
Yeah.
So let me get this clear. So when we make a new object, all we're doing is just like having one of the array pointer point to the new object that we made, right, in heap?
That's correct. If
Okay.
you create a new object, right?
Yeah.
If you create a new object, normally you create a new object, it's not that you are taking it from here. You create a new object is typically is that you create it somewhere else, and then just get an address and try to address to insert or find it stored somewhere in here.
Mm-hmm. Okay, got it.
Good?
Yeah.
Okay. So let me clear up all my stuff. All right. So then the next one. Sorry. So the next one is also a hybrid, okay? What is this? Is that we can implement a linked list with arrays. So those are really the same kind of data, A, C, and B, okay? A, B, and C. And this is a linked list, but we'll implement this linked list as an array. Well, of course, there's a condition here will be because it's implemented as an array, this whole thing needs to be fixed size, okay? So this is a fixed size array. But within this array, really, this will be okay. Basically, this is the next field. And this is the object itself, the item itself. So the array start is started with A, whatever the thing that's pointing is just started with the A. And this guy is the next is number 4. So 0, 1, 2, 3, 4. So B would be the 4. Using index as the pointer. Okay? Using index as a pointer. So A is next is 4. 4 is B here. And B's next is 1 is C. And C is next is -1 or 0. Well, actually, can I use the 0? So this is really the end of it. Good? Okay, so suppose you need to have a tail. If you want to have both head and tail on your data structure, your head will be 0 and your tail will be 1. Okay, so very much what we are doing here is that instead of putting a node address into it, we very much is using one of the array's elements, okay, to designate the array's index to designate as a pointer. Does it make sense? So what's the benefit of this? Okay, for example, if we do an insertion, suppose we want to insert another one in here. Okay, so this is the D. Basically, what we end up with is doing this, right? Okay. Now you can easily just go to any empty spaces, find any empty spaces and put a D in there. Then manipulating what? Manipulating that B's next goes to 2. Pretty much it's exactly the same thing as that the D's next is go to B's next, so it's the 1. Okay. Then B's next become D, so D is 2. Then you accomplish the insertion. And deletion is the same, the identical scenario, depending on which one you're going to delete. Then you manipulate the pointers. Pointer in this scenario is manipulating the index. Clear? So if we got a double linked list, what happened? Basically, it's another field in there. It's called previous. Okay, so it's just adding one more field. That's a previous. That's a double linked list. Okay. Now, what is the benefit of this data structure organized this way? You organize it this way is that, first of all, you don't really need to move any of those objects. Once your objects stay in your arrays, you will stay there. You don't have to pack them either. Okay. In the previous approaches we just talked about the last 10 minutes. Okay, because it's a packed array, so you need to move the things up and down, depending on how you insert it. That's why we only have, even if we only have a pointer, we still need to move the pointers up and down. Okay, but by using the index here, then we don't really need to move anything. Pretty much is we change the index to change the direction, change the sequences of all these objects. Clear? Any questions? Okay, so any questions about those hybrid?
So they're both just arrays pretty much then, right?
Pardon?
Both just pretty much arrays, except I guess one of them has the memory location being, I guess, specified.
That's correct. Do you know why? Do you know why? Because linked list, because it involves a lot of pointers, okay? And does it have advantage? Yes, it has advantage, except that most of the people are quite familiar with arrays. And arrays are simpler to conceptually to understand, okay? And also to debug. Because you can always print out the whole array and actually take a good debugging of it. Okay, and so array is a lot more simple in terms of how to implement it correctly. Linked list has more complications, so people try to figure out how can I take advantage of the linked list functions, but we still have the simplicity of arrays, and that's what this hybrid data structure comes in. All right. Okay. So if you are okay with that, I think you have seen this already, right? Yeah, this is very much. So take one example, okay? On your take-home quiz, suppose we change those forward linked list to double linked list with a different type of stuff, then all your answers will be different.
All you
Okay?
need to do is just change the previous and next. I don't know. That's all you really need to do, right? I think that's just the difference between them.
What's that?
Instead
Oh,
of just changing one thing, you'd have to change two in this case.
well, yeah, I mean that the whole thing is that your algorithms may be all different because of you have more complications in terms of how do you deal with the link, previous, next, and maybe what if we also add length, right?
Yeah. Okay.
Yeah. Got it? Okay. So how much time we have left? No time. Okay. Next time, let me just explain to you on Wednesday what we're going to cover. Okay. Very much if you attend the seminar, the guest lectures seminar on Monday, okay, we're going to cover the recursions, okay. But fundamentally, the approaches I'm going to take on the recursion is that recursion iteration I want to emphasize on is emphasize that the advantage part of the recursion, not that in the sense is that can it be done or not? Yes, they can be done. I think by now, especially that the guest lecture focus quite a bit on saying, okay, is Thomas around on the call? Okay, I think Thomas was being asked to say, oh, everything you can do with the recursion, can you do with the iteration? Well, the answer is yes, you can. And everything you do with iteration, can you do with recursion? Yes, you can. Okay, and so technically, both of these are really the same thing. Or you can solve the same problem, except that there are reasons you want to use the recursion, and that's what we want to emphasize on. All right. So if you can't, go to this page. Okay, go to this page and then try to see how much you can get out of it. And then we're going to focusing on the part which iteration is hard. Okay, and when the iteration is hard, we're going to be this guy. That is a very famous problem, Tower of Hanoi problem. So we will try to show at the end of the day, okay, to solve this problem, all you need is 5 lines of code instead of your brain has to go through it. Okay, so take a look at the recursion section, and then on Wednesday, hopefully we have a good discussion. And also, okay, the format we are doing it today is probably going to be continuing for a little while. And if you have any comments or suggestions, or Frank, don't do this or don't do that, please either drop me a personal mail or just put it into the canvas. All right? Help me help you to learn stuff.
Will these be uploaded somewhere, or
Which one?
will the lectures be uploaded somewhere, or are they just
Which lecture?
these ones, the ones that you're doing right now?
Yeah.
Oh,
Where are you gonna upload them? Like YouTube, Canvas, or?
okay. You know, I think I will try to figure out is where the video is, and if it's on my computer, I will go ahead and upload to YouTube and I'll post the link.
All right,
I
that
probably,
works.
I probably
Okay.
would do. I probably would do a little bit to speed up because I'm kind of slow poker. Okay, and then I'll post it before the end of the day. If it's on my computer, if it's on the Zoom, I have no idea. So I need to figure it out and let you know.
Okay.
All right,
Okay.
thank you.
All right.
Thank you, Professor.
Any other questions you have?
Oh, can you go over the second implementation of the hybrid list again using like the 2D,
Let me try it.
like a 2D array, I believe?
This one?
Like the 2D array part, like where you said that we don't have to package, like move around the objects in the array. We can just use the second part of the array, if that makes sense.
Yeah, it's right here. Okay. See, look. So you talk about here? This one, right?
Oh, so this is the 2D array.
Well, it's what is this a 2D array? Okay, but you know the other way to look at this would be you make a sort of objects and the index. Yeah. Okay.
Yeah.
Yes, you can call it 2D array, but you know you can actually just having two arrays. It's the same.
Okay.
Yeah. Okay. It's one array of objects, one array of index.
Yeah.
Make sense?
Yeah,
Okay.
it makes sense.
I think honestly, if I'm implementing it, okay, I will do two arrays. This array will be the object array, whatever the stock or students or whatever. Okay. Then on this one, pretty much I will just do an int, array of int, because it's the index of into this whole thing.
Yeah.
Yeah.
And the integer array, all it's doing is like telling the program to go to this element of the next, like in the array, right?
Well, for this one, the examples we are using, this is really the next, right?
Yeah.
Yeah. But if you, so this is really just the next. Now, can we have another one, the previous? Of course we can. You know, then that becomes double linked list.
Yeah. Okay. I get it.
So, you know, one thing I hope you learned is that as long as you understand that the whole structure of this and how to manipulate that, the implementation of it is either this kind or the other kind or the traditional kind. It doesn't matter. As long as you understand that, okay, I have to deal with the pointer here, pointer there, and all that stuff. Okay. Now, which way you're going to implement? It all depends on that how your environment will fit you. All right. See, for example, if my objects are videos, I definitely will not use this. If my objects are videos, I will use the previous guy. You know, if my objects are videos, I would definitely either use the traditional linked list, or I will use this because of variable size nature of the object. All right. So stick with that your traditional one, but keep your mind open to you could have a hybrid.
Okay, for sure. Thank you so much.
All right. Other questions you have? Okay. So if there are additional things you need from me or something I can help you, just shoot me a mail. All right.
Thank you.
Okay. Right. Bye.